Welcome back to Mr. Erlin's Geometry. In this lesson we'll be constructing an angle bisector. As it sounds, an angle bisector cuts in half or bisects an angle. So in concept what we're looking for is the ability to take this angle and find exactly what will cut it into two equal angles. To do this we'll use our traditional construction tools, a compass and a straight edge. To begin with, as we do with most constructions for an angle, we open our compass up to an appropriate size such that the needle is on the vertex and the pencil can draw an arc cutting across both rays. This establishes some foundations from which we can make a lot of constructions. You'll notice that what it gives us is points of intersection, the intersection of this arc with each of the two rays. You might remember when we did segment bisectors that we began with a similar concept. With these two masterful endpoints, we simply go more than halfway, make an arc, and then from the other endpoint do that same distance, which is more than halfway. And by connecting those endpoints of our little football, we're able to produce a segment that is both perpendicular and evenly splitting this segment in half, thus a bisector. Well, the same concept is going to apply here. But instead of using endpoints of a segment, we're using endpoints of this arc. Having established my initial arc on my angle to be bisected, I'm going to adjust my compass from this yellow point to be more than halfway to the other yellow point of intersection. It doesn't matter where, as long as it's more than halfway. I prefer to ensure that it does not go through the vertex as well. You'll see in a moment why that's important. I make a half circle with that. And I carry the same measurement in my compass to this other ray and make another corresponding arc from the other side. If I've done this correctly, what I'm going to produce is points of intersection here, and they should line up and be collinear with my original vertex. If they don't fall in a line, then that means I've made a mistake in my construction. It's for this reason that I suggest when we choose our initial compass width, we don't go through the vertex. If it went through the vertex, this football would be a little bit larger, such that I get only 2 points. And as we know, any 2 points are collinear, therefore I'm not getting any extra check to confirm I did it correctly. 3 points are only sometimes collinear, therefore they're only going to work if in fact I've done it correctly. By connecting these 3 points, I should be able to produce a ray extending from the vertex out into the angle in such a way that this arc and this arc are congruent. I've successfully bisected the angle. Let's try it one more time for practice. This time we'll do it with an obtuse angle. First step, make an arc any size as long as it covers both arcs, both rays, Choose an angle measurement on my compass that's larger than halfway, that's not through the vertex. Same from the other side. And again, even if this goes through a point outside the angle, on the exterior of the angle, I still find 3 points that are collinear. Thus, when I produce the ray that's formed by these 3 points, I'm going to go from the vertex out as opposed to including this point out here. I produce a ray that bisects this angle, cuts this angle into two congruent segments, into two congruent angles. Thanks very much. See you next time.